So yesterday we learned the very last derivative rules that we're really ever going to have to learn for this class. But what we need to talk about now is the domains of exponential and logarithmic functions. So if I, for example, well, let's start with this. If I, for example, said at what point on the graph does this line have a slope of 21? Tangent line immediately tells me I better take a derivative here. The derivative would be 2 to the t power times the natural log of 2. I want to know where the slope is equal to 21. So I'm setting this equation equal to 21 because I want to know where the slope is 21. Then I'm going to solve this. So I would divide by the natural log of 2. And then in order to get the t to drop down, I would have to natural log both sides. So I would get t times the natural log of 2 equals the natural log of 21 divided by the natural log of 2. And then to get t by itself, I would have the natural log of 21 over the ln of 2 all over ln of 2 again. So let's see here. If I find my calculator, I'm going to type that in so I can see at what exact t value this actually happens. Let's see. So I have 21 divided by the natural log of 2. Oops. 21 divided by the natural log of 2. Then I'm taking the natural log of that number, and then I'm dividing by the natural log of 2 again, which gives me 4.921. Now you'll notice that in this question it didn't say at what x value, it said at what point on the graph. So in order to figure out the point, I'm just going to make the t value the x. And then I'm going to plug that into the original function. In order to get the y value. So I would have 2 to the, this stuff, minus 3, which is 27.297. A line with slope m passes through the origin and is tangent to the graph y equals natural log of x. What is the value of m? So when I see tangent, and I'm talking about a tangent line, I know I need a point and I need a slope. The slope, it tells me in the problem, is m. But the slope would also be the derivative of my function. So it would need to equal 1 over x. Now if I write the equation of this tangent line, it tells me in the directions that the tangent line goes through the origin. So the point that it goes through would be 0, 0. And the slope is 1 over x. So I would write y minus 0 equals 1 over x times x minus 0, which if I simplify that would just be y equals 1. Now here's what we need to know. We want to know the value of m. So we don't need y, which we calculated here. We need x. To figure out x, we're going to take this and we're going to put it into the original to calculate x. So 1 equals the natural log of x. What number could I take the natural log of that would give me 1? X would have to equal e. Which means my final answer for m is that m is 1 over e. Let's go through this one more time. I see in the directions it says my slope is m, I go through the origin, and I'm a tangent line. So I know right away my slope is m has to be equal to my derivative, because it's a tangent line. I also know that going through the origin means that I go through the point 0, 0. So now I've got a slope, I've got a point, I can write an equation. When I simplify that equation, I get y is 1, which is great. But in order to figure out the m, see it says what is the value of m? I need to know x. Well, if I've got y, I can plug it into the original function and I can get x, which means that I can use to actually calculate the value of m. This is actually an AP FRQ that came up a couple years ago that a lot of students got stumped on. So I'm hoping that by going over this now and by making sure that we can see the sort of the idea here, the process, we won't get stumped on it if we see it again. Now, as a review, when we talked about domain way back when you guys were in pre-calculus, we said the domain of a logarithm is that the inside stuff needs to be bigger than 0. The domain of a rational function is that the bottom of a rational function cannot equal 0, otherwise you get a vertical asymptote. And we said that if you ever have an even root, like a square root or a fourth root, the inside stuff needs to be greater than or equal to 0. Because of that, we know that the domain of the original function affects the domain of the derivative. So, if your function is add the natural log of x minus 3, find the derivative and then state the domain of the derivative. Well, let's start with just finding the derivative. The derivative of natural log would be 1 over the stuff times the derivative of the stuff, which in this problem would just be 1. But here's the thing. Your derivative cannot exist in a place where the original function did not exist. Can only exist in the same domain as the original. So because the original function here was a natural log, it has a domain problem. The domain of the original function can be found by saying, okay, x minus 3 needs to be bigger than 0, so x needs to be bigger than 3, which means this is also the domain of the derivative. And that's actually it for today. Couple application questions, we're good. I'll see you guys tomorrow.